China has a robot roaming Mars right now, and it's already uncovering some strange clues that raise a big question. Are we closer than ever to finding life on the red planet? This rover, named Zhurong, is medium-sized and built much like NASA's Spirit and Opportunity from 2004. And honestly, for China's first attempt on Mars, its success is remarkably impressive. China's Zhurong rover didn't travel to Mars alone. It launched aboard the Tianwen-1 mission in the year 2020, marking one of the boldest leaps in China's space history. Before this, China had only achieved 2 successful lunar landings, so moving straight to Mars was nothing short of ambitious. And remember, landing on Mars is a challenge that only 3 space programs had ever pulled off. The Soviet Union managed Mars 3 back in 1971. The United Kingdom tried with Beagle 2 in 2004, but it failed to fully deploy after touchdown. And of course, NASA has been landing and operating rovers since 1976, continuing all the way to today. So when China entered this arena, it stepped onto one of the toughest stages in planetary exploration. When China prepared to land Zhurong on Mars, they chose Utopia Planitia, a wide, flat, forgiving landscape that's perfect for a first attempt. This region is believed to be the floor of an ancient ocean basin, meaning that beneath all that calm, sandy terrain, the planet may be hiding traces of a watery past. Meanwhile, NASA took a very different approach in the same year, 2020. Their Perseverance rover dove straight into Jezero Crater, a rugged environment carved by ancient rivers, filled with cliffs, valleys, and a fossilized delta. It's a far riskier landing zone, but scientifically it holds incredible promise. And that's the fascinating contrast. While Zhurong touched down somewhere smooth and quiet, even those gentle plains may conceal the oldest secrets Mars has ever held. Now here's where the story takes a surprising turn. Utopia Planitia isn't just a safe landing zone, it's the same place where Viking 2 touched down in 1976. And some scientists still wonder, did NASA accidentally discover life on Mars nearly 5 decades ago? Viking ran an experiment where nutrient-rich water was added to Martian soil, and immediately the sample released carbon dioxide. Exciting, right? But when a second dose of water was added, the carbon dioxide levels dropped. NASA interpreted that as proof of no life, yet an alternative theory has gained traction over the years. If Martian microbes had adapted to ultra-dry conditions, then soaking them with too much liquid might have overwhelmed them. In other words, it's possible the experiment didn't fail. We might have drowned the very life we were searching for. When it came time for China to land Zhurong on Mars, they didn't chase flashy new technology. They went with something old school, simple, and incredibly reliable. Remember how NASA experimented with giant airbags in the 90s and 2000s, bouncing rovers like beach balls across the Martian surface? And then later, they upgraded to the iconic sky crane system, lowering Perseverance on cables like a robotic superhero. China, meanwhile, chose a method that dates back to the Viking era nearly 50 years ago. Parachute first, then a controlled descent using a rocket engine, and finally shock-absorbing legs to cushion the touchdown. And here's the twist. It worked perfectly. As soon as Zhurong touched down, it unfolded its solar panels like wings greeting the Martian sun, rolled down its ramp, and drove straight into history as China's first successful Mars rover mission. But the team on Earth knew they were racing against time. Because Zhurong relied entirely on solar power, the mission was officially planned for only 90 days. They expected that Martian dust storms, famous for coating panels and blocking sunlight, would eventually bring the rover to a silent stop. Now that Zhurong was safely on Mars, the real adventure began, and the rover wasn't wandering the red planet empty-handed. It carried 3 essential scientific tools that would help China peel back the layers of Martian history. First was a full camera array, mean for the search for life. It means Mars had suitable conditions not just once, but twice. It means life didn't have a narrow window to appear. Zhurong's journey across the Martian dunes revealed something no one expected: a thin, salty crust covering the tops of long, low sand ridges. At first glance, it looked like hardened soil. But when scientists examine the structure, the chemistry, and the depth, about 8 centimeters, they realize this crust could only have formed through one process, liquid water. And that raises a huge question. How does liquid water appear in one of the driest environments in the solar system? The leading explanation is surprisingly elegant. Water vapor from the polar ice caps drifts southward during certain climate cycles. That vapor condenses into snow, settling on the dusty dune surface. But the snow doesn't stay frozen forever. Mars's ancient oceans left behind salts across the region, and when snow mixes with salt, it can melt at much lower temperatures, creating brief moments of liquid water that seep into the outer layer of the dune. Eventually, that meltwater evaporates, leaving behind a hardened, crackly crust of salt and dust. Now here's the part that truly rewrites the story of Mars. This process didn't happen billions of years ago. Based on Zhurong's measurements and sediment chemistry, it may have occurred as recently as 400,000 years ago. Think about that. While early humans and Neanderthals were roaming across Earth, hunting, gathering, and shaping stone tools, Mars may have been experiencing snowfall, real snow, real meltwater, real hydration cycles. So what does that tell us? Mars is not just a fossil world frozen in time. It is a planet that continues to breathe, shift, and change through long climate rhythms. And if water has been active this recently, even in small amounts, then the window for potential Martian life, past or present, might be far wider than we ever imagined. So now we get to the really fascinating question: why was Mars able to have snow, meltwater, and hydration cycles long after its ancient oceans disappeared? The answer lies in something surprisingly familiar: long-term planetary climate rhythms, very similar to the Milankovitch cycles that shape Earth's ice ages. Scientists now believe that Mars also goes through slow, powerful shifts in its orbit and rotation that dramatically reshape the planet's climate over tens of thousands, even millions of years. First, there is orbital eccentricity, the way Mars's path around the Sun slowly stretches from nearly circular to more oval over cycles lasting hundreds of thousands of years. A more oval orbit means bigger temperature swings, which can warm the polar regions enough to release water vapor. Second, Mars experiences large variations in axial tilt. Earth's tilt wobbles between 22 and 24 degrees. Mars, however, can tilt far more dramatically, creating extreme seasons. When the tilt becomes high, sunlight strikes the poles more directly, causing buried ice to sublimate into vapor. Third, there is axial precession, the slow wobble of the planet's spin axis over cycles of tens of thousands of years. This changes the timing of seasons and shifts where sunlight hits most intensely. Together, these cycles occasionally line up in just the right way, warming the poles, releasing water vapor, spreading snow across the northern hemisphere, and allowing salty meltwater to briefly hydrate the dunes. And when all three cycles overlap in their most intense phases, the effect could be far greater than a few snowy seasons. Some researchers believe that once every billion years or so, Mars might experience a rare climate alignment powerful enough to cause widespread flooding, briefly reviving parts of the ancient hydrological system. So when we look at those crusty dunes and hydrated minerals Zhurong found, we're not just seeing geology, we're seeing the signature of a living climate rhythm, slow, subtle, and ancient. A rhythm that might still be beating today, shaping Mars in ways we are only beginning to understand. Remarkably, Zhurong far outlived its original mission, surviving for 358 days before losing contact after a massive dust storm in the year 2022. And now China is preparing for its most ambitious step yet. In the year 2028, they plan to launch the first mission that will bring Martian soil back to Earth. For the first time in history, scientists will be able to study Mars directly in their laboratories without relying on remote instruments. And with that, we may finally uncover signs of Martian life without accidentally destroying it. Maybe next time we spare the aliens, though we probably